All right, now we're going to learn the official or the formal definition of a limit. The limit looks like this, right? The lim x approach to c f of x equals to the limit, which is a number. And here c is a number, l is a number. So what is the official definition of that? We call this is epsilon delta definition. Okay, so that means for each epsilon greater than 0, there exists a positive delta such that when x minus c is between 0 and epsilon, such that f of x minus l less than epsilon. So what it says is this. That means for each epsilon greater than 0, you want the function value at that point, at this x point, or f c, minus this limit l. But at c this f of x might not have the definition at the point c. We have seen this a lot. We have seen that there's like a piecewise function or something like that, or f of c might not exist, or was not defined. So that's why, did you notice that x minus c is less than delta but greater than 0? That means it doesn't require this function is defined at the point x equals c. However, the f of c, which is a function value minus a fixed number, or which means the difference between the function value and whatever number, the limit number, got to be less than epsilon. For if I give you an epsilon, you can find a delta. So if I give you that the function value is within like a small interval of that L, then there exists a delta that the x must be somewhere around this c, point c, with a plus minus delta. And it got to be greater than 0. We don't really care about that. So this is the official definition. It's like tongue twisting. It's really hard at the very beginning to understand. But let me give you several examples that will help you to understand what does this mean. So as long as you can remember that x approach to c, and here you have a greater than 0, it might not have the definition when x equals to c. X doesn't need to be c. And this x is, so this x minus c is less than delta, which means x minus c, okay, if you get rid of this absolute value sign, it got to be between negative delta and a positive delta, okay? And it may not be 0. I don't care whether it's a 0 or not, but that's between that. So this one, it says f of x got to be between L plus epsilon and L minus epsilon. So that's when you change the definition part from the absolute value. Okay, I know you lost. You already lost. But let me give you one example. Example 1. Given the limit x approach to 1, 2x plus 1 equals to 3. I tell you that. But actually it's fairly easy, right? When x goes to approach to 1 from both left and the right side, then 2 times whatever number close to 1 is going to be 2 times 1, 2 plus 1, that's 3. So given that, and then I ask you to find a delta. Find a delta for a given epsilon. And I give you this epsilon equals 0.01. Okay, so I give you the epsilon is 0.01, ask you to find the delta, which means I give you the little interval for the a little interval for the function value or in the range. I ask you to find the thing in the domain. Okay, so what it says is this: for a given epsilon, remember epsilon is this, right? It's f of x minus L is less than epsilon, right? So in our case, f of x is 2x plus 1, and then minus L, which is minus 3, less than 0.01. So this is a given. All right. Now I need to find what is about this x around 1. So that's how you find delta. All right, now we're going to solve this a little bit. So we open the parentheses and we get 2x plus 1 minus 3 less than 0.01, which is 2x minus 2 less than 0.01. Okay, I will continue. I got a 2x minus 2 is between 0.1 and a negative 0.01. So from here to here, I thought you know how to open the absolute value sign. And then I plus 2 on both sides, so I get 2 minus 0.01 less than 2x less than 2.01, which here is 1.99 less than 2x less than 2.01. I hope I'm not going too fast. And the next step, I'm going to divide it by 2. So I get an x is less than 1.005, and here divided by 2, I will get a 0.995. Okay, so, and I need to find a delta. This delta is x minus c is between that. So therefore, I will go x minus 1 because x approached to 1. So everywhere minus 1, so that will be 0.005, and here will be negative 0.005 because 0.995 minus 1 is negative. That, do I get it? Yep, I get it. Negative x minus 1 absolute value is less than 0.005. So that is, did I find my delta? Yes, my delta is 0.005. That's my answer. Okay, so if you want to show me when you do the quiz, then you probably need to go to the steps to show me how you get a delta. For a given epsilon 0.01, can you find the delta? And this is like a solving an inequality, isn't it? So that's how you do it. Which means for any given for any given epsilon value, or for give you 0.001, I want the function value, I want the f of x is within plus minus 0.001 of 3, around 3. So it's from 0.001 above 3 and below 3. So I want the function value between that. I can go to find that x must be within 0.005 of 1. That's what it says. That's the official definition of that. It's kind of interesting. So in this example, it's called find a delta for a given epsilon. I give it the epsilon. Then you put the epsilon in this situation, f of x minus L, absolute value less than epsilon. Then you're going to go ahead and solve for x minus c, absolute value of that, to get delta. All right, now let's work on the second example. The second, ignore this question mark. Let me just switch that. Okay, so what about I didn't give you a fixed number for epsilon. Can you also find a delta? For example, I ask you to do this. I ask you to use using the epsilon delta definition of limit to prove It just asks you to use the definition to prove it. What does this mean? Okay. I ask you to prove. I ask you to use the delta epsilon definition of limit to prove this. To prove limit x approaches to 1, 2x plus 1 equals 3. Can you prove it? Which means for any, the definition, for given epsilon greater than 0, there exists a positive delta such that, this is the question, and here is the definition. Just repeat the definition, that the function value of x minus L absolute value is less than, for any given delta, there exists that, which is x minus c is less than delta. Okay, so let's see. For a given epsilon greater than 0, so we know this. Okay, given, this is a little different than the previous example. The previous example, I gave you the epsilon is 0.01, right? But this, in this case, I didn't say anything. I just said positive that. Prove it. F of x is 2x plus 1, then minus 3, absolute value less than epsilon. Right, now let's simplify this. I get an absolute value of 2x minus 2 less than epsilon. And we have the epsilon is positive, we know that. So I get a 2x minus 2 got to be between epsilon and a negative epsilon. Did I say? Yeah, sorry, here, plus 2. And then I go plus 2, plus 2, plus 2. So I have a 2x less than epsilon plus 2, epsilon negative x, negative epsilon plus 2. Okay? And then I want to deal with this c. What is my c? C is 1. So, okay, one more step. I go divided by 2. So I get epsilon plus 2 over 2. Negative epsilon plus 2 over 2. And then I go x minus 1 got to be between epsilon plus 2 over 2 minus 1, because I'm subtract 1 everywhere, and then that will be the x minus 1 is less than, is greater than, and this is a 2 over 2, subtract that, you get just this. Okay, so do you get a delta? Because from here you get an absolute value of x minus 1 that we, right? So it's less than, and that is that delta we found it. The delta is just epsilon over 2, and that's it. So we are using the definition C for each given epsilon. The function value is within the epsilon of the limit. We can always find a delta that, we can always find the delta that x is around the C plus minus delta. And in this case, we find the delta because we just, for whatever given epsilon, we just divide by 2, which agreed with what we just did earlier, right? If I give it the epsilon is 0.01, and then we find our delta is 0.005, right? Half of that. So we know how to find the delta given for a given epsilon value. And second example is, if I didn't give you the specific epsilon value, I just ask you to use the epsilon delta definition of the limit to find, to prove a limit. Not bad at all, right? Okay, so we're going to work on one more example. of one more example. Okay. So I ask you to use epsilon delta definition to prove this. Limit x approach to 2, 1 over x equals 1 over 2. Use this definition to prove this. Okay, so that means you want to show that for each epsilon, positive epsilon, then there exists a delta, such that the function value minus the limit less than epsilon whenever the x is within the delta of 2. So prove it. Okay. Which means for each epsilon greater than 0, and we have, remember, I just write it here, f of x minus L, okay, less than epsilon. So that is 1 over x, that's my function, and the minus the limit is 1/2 absolute value less than epsilon. And I want to show that for each epsilon greater than 0, and we have this, there exists a delta that x is within 2 plus delta and 2 minus delta. All right, now we're going to simplify this a little bit. So this is the absolute value, therefore I get a 1 over x minus 1 over 2 has to be between positive and a negative epsilon, plus 1/2 everywhere. So I get a 1 over x, okay, so I get 1/2 plus that, and a 1/2 minus that. How do I go ahead to get something about x? You might want to flip it, and we know this is positive, and we let epsilon less than 1/2. The reason I let it to be less than 1/2 because I want this to be positive, because I don't want to deal with a negative number. Again, for each given epsilon, usually the epsilon is fairly small, so it doesn't hurt if we let epsilon is less than 1/2. Then we just flip it. So if you have like this is less than a, so do you get this x is greater than a if a is a positive? Would you agree? Because x, because this 1 over x, this is a reciprocal function, or x to the -1. It just it's a decreasing function, so it looks like this. Okay, so when x is greater than 1 over x, it's smaller. So basically that's what it says. Okay. So when 1 over x is less than 2, 1 over x is less than 2, then x must be greater than 1/2. When x is greater than 1/2, then 1 over x is less than 2. That's what it says. Okay, so we're going to flip it and then change the direction. Flip, so that's going to be 1/2 plus epsilon, there's 1 over 1/2 minus epsilon. Did I change? Sorry, I gotta change. See, I forget things. Okay. All right, now next, because I need x approach to 2, so I'm going to subtract 2. So x minus 2 is going to be 1/2 plus epsilon minus 2, and here is 1/2 minus epsilon minus 2. Wow. Okay. Still, it's not bad. So let me just simplify this at the side. All right. And then the denominator, I find the common denominator is 2, so it's going to be 1 plus 2 epsilon. Would you agree? Right. So epsilon is epsilon over 1, so that's that. and then 1 over a fraction, we just flip it. So it's going to be 1 plus 2 epsilon minus 2, right? And this is, again, this is 1 plus 2 epsilon minus, and this is 1 plus 2 epsilon, and the numerator is 2 times 1 plus 2 epsilon, out of space. And the denominator is 1 plus 2 epsilon, and the numerator becomes 2, okay, minus 2 minus 2 epsilon, and this 2 and a 2 cancelled out, so I get a negative 2 epsilon. That's this part. So I get x minus 2 greater than, I just write it, I copied from here, so 1 plus 2 epsilon. And I'm going to work on this side. This side is minus, okay, so it's a 1/2 minus. So here it's going to be minus, and here is minus, and here is minus. It's very messy, but sorry, forget about that. Let me do that again here, because I need to simplify this, and then I can put the answer here. I just do this like 1 over, so it's, okay, I'm simplifying that part, so that becomes 1 over 2, and it's 1 minus 2 epsilon minus 2, so that becomes 2 over 1 minus 2 epsilon minus 2, that becomes 1 minus 2 epsilon 2 minus twice of 1 minus, because I find the LCD 1 minus 2 epsilon, and then I simplify this a little bit. The denominator is 1 minus 2 epsilon, and the numerator 2 minus 2, which is gone, and this negative become positive of 4 epsilon, so I get a 4 epsilon 1/2 minus epsilon. And remember, I assume my epsilon is less than 1/2, so this is a positive number, and here is a 4 epsilon over that. Did I get that? Yeah. So you might wonder, well, this is a negative number, right? Yeah, so this is a negative number, and this x minus 2 is between a positive and negative number. So what about the absolute value of, oh, I'm out of paper. Let me get this right here. So once you have this, then you're going to have x minus 2, the absolute value is less than the maximum of absolute value of a negative 2, 1 plus 2, and the other one is a 4 epsilon 1 plus 2 epsilon. I don't know which one is greater, but whatever the greater one could be, that will be my delta. Okay, so my delta is the maximum of this 2 absolute value. I don't know which one is greater, because it really depends on where you choose, how much you choose this epsilon. But anyway, we find delta, and you probably want to, because if you think this is too complicated, and you can just pick an epsilon. You can pick the epsilon becomes like a 1/4. Okay, if you put epsilon is a quarter or 1/4, then you can just plug it back and to find the delta. Should I do that? Let me just do it. Okay, since I have time, I just do it. If you choose epsilon is a quarter, which is I think it's fairly small, isn't it? So that means 1 over x minus this is less than 1/4. You agree? And then so 1 over x minus 1/2 is less than a quarter and a negative quarter. Okay. Then I plus a half, so I get a quarter plus a half is a 3/4. I'm going pretty fast, isn't it? Okay. Therefore, I have x, I flip it, change the sign. Now I remember. Okay, 4 over 3 and a 4. All right, and then I go x minus. I want x approach to 2, right? So minus 2. So that will become 4 over 3 minus 2, and here will be 4 minus 2. So I have x minus 2 is greater than, this is negative 2/3, and this is 2. Therefore, because my x minus 2 is between 2 and this guy, and I got x minus 2, the absolute value got to be less than 2. So that's my delta is 2. So for the given absolute value 1/4, I got a delta. You see how the process works? If I give you an epsilon, and then you go with this and then you work on that because you have a number, so it's much easier, and then you can get the delta. And so by this, you're using the epsilon delta definition. You proved this limit. You proved that x approaches to 2, 1 over x becomes 1/2. So you use the definition to prove that. The little bit harder part is for given epsilon. I didn't give you the specific value for epsilon. So all the calculation, you have to carry this epsilon with you. Okay? So this is how you use the how you understand the formal definition, the epsilon delta definition of to get the limit, and you can prove that this limit is does exist. Okay? So this is a little bit harder than the previous classes, isn't it?